In section 3.4, we'll be learning about derivatives of inverse functions. So you should remember from pre-calculus, the inverse functions are functions whose domain and range have been switched. So like those were the problems where you switch the x and the y and then you solve for y. And so the property that we would keep in mind for inverse function is if you do the composition of a function and its inverse, you would get x. And so that's this right here. So if we have f of f inverse of x, that is equal to x. Remember that when we see this -1 here, that means inverse and not reciprocal. Okay, so we're going to use this identity from inverse functions in order to find the derivative. So I'll take the derivative of both sides. I'm using implicit differentiation here. So the derivative of f is f prime. And so I will be using chain rule here. So I have an inside f inverse, outside f. So the derivative of that would be f prime of f inverse of x. I leave the inside the same. And then I multiply by the derivative of the inside. To help us keep track of our notation, I'm going to write it as f inverse of x and then put the prime outside those parentheses just so I can keep track. That's the derivative of f inverse. That is equal to the derivative of x, which is 1. Now what I'm trying to solve here is for the derivative of f inverse. That's this part right here. So to get that by itself, I would divide by everything that was in front of it. So I would have 1 over f prime of f inverse of x. And that is the derivative of the inverse. This is something you will want to memorize. It's on your Stuff You Must Know cold sheet. If you don't have it memorized, then you're just going to have to figure that out every time. It will be much easier if you can memorize that. So in number 1, it says, suppose that f of x is 3x plus 2, and we know that f prime of -2 is 3. What is the value of f inverse of -4 prime? Now, even though this is asking about f inverse, that doesn't mean I actually have to find f inverse. What we're going to do is use that formula we just talked about. So f inverse of -4 prime means I would do 1 over f prime of f inverse of -4. Now we'll need to figure out what f inverse of -4 is first. And so let's just do that over here. F inverse of -4. That means, so if the x value here is -4, for f of x that would be the y value. So that would mean f of x is equal to -4. We want to figure out what that x value is. And so to figure it out, I'm going to take f of x, it was 3x plus 2. Set it equal to -4, and I'm going to solve for x. And so since f of -2 is -4, then f inverse of -4 is -2. So this is actually equal to 1 over f prime of -2. So f inverse of -4 was this -2. I'm just plugging that right in there. Now that was the value that was given to me. My answer is 1 over 3. So more likely than not on the AP exam, you might see these derivative of inverse functions with a table of values. So it's not actually going to give you the function, which could be nice because then you're not tempted to go and spend the time finding the inverse. And so what we have here, we have f, g, f prime, and g prime, and it's going to ask us to find some derivatives. So we want to find first f inverse of 3 prime, and so we're going to use our formula 1 over f prime of f inverse of 3. And so in order to find this f inverse of 3, remember that means that the 3 is my y value for f. So if it's the x value for f inverse, it's the y value for f. So when I go over to my f column, I'm actually looking to see where is there a 3 in the f column, not in the x column. And then I notice that the x value there is 1. And so that's what I'm going to put in for f inverse of 3. So remember, inverses, your x's and your y's are flipped. And so this is really 1 over f prime of 1 And then I can see that. I'm going to look at my f prime column and go down to the x value 1, and I see that it's 2. So this is 1 over 2. Next, we're going to find g inverse of negative 2 prime. So again, we'll start out, we have 1 over g prime of g inverse of negative 2. And so when we want to find g inverse of negative 2, that means we're going to go in the g column. Notice I'm in the g column, not g prime. And I'm looking for when the answer is negative 2. Again, that is 1. So this is 1 over g prime of 1. And so then I'm going to, in the row with x equals 1, find g prime. That is 1. So 1 over 1, which is just 1. In part C, we want to find the value of g inverse of 1 prime. Then we'll find the equation of the line tangent to the graph of g inverse when x equals 1. So let's start off. G inverse of 1 prime is 1 over g prime of g inverse of 1. So I'm going to find g inverse of 1 in my table. So I'm going to the g column. I'm finding when the y value is 1. And then I'm looking at the x value. I see that that is 3. So this is 1 over g prime of 3. I can see that g prime of 3 is negative 2. So this is negative 1 over 2. That's the slope of my tangent line. Remember, the derivative is the slope of the tangent line. I still need my point, which we actually found already, but we're going to write it out. So g inverse of 3, or sorry, not of 3, of 1 is 3. That's the 3 that we found before. So again, g inverse of 1, I go to the g column, find the 1, and it's at 3. So my point is 1 comma 3. And now I can write my equation. Y minus 3 equals negative 1/2 times x minus 1. Okay, now let's actually try out some AP examples. So in part A, we have let f be a differentiable function. That just means we can take its derivative, such that f of negative 4 equals 12, f of 9 equals negative 4, f prime of 4 equals negative 6, f prime of 9 equals 3. That's a lot of information. It's kind of like what we've had in the table in the previous problem. It's just written out. We know that g is equal to f inverse for all x. What is the value of g prime of negative 4? So we know that g is the inverse, and so this is actually asking for f inverse prime of negative 4. So we know our formula for that is 1 over f prime of f inverse of negative 4. And so we just need to figure out what that is. So in order to find f inverse of negative 4, I'm not going to look at f prime of 4 or f of negative 4. I'm going to look to see where f is equal to negative 4. That's right here. So f of 9 equals negative 4. And so that means f inverse of negative 4 is 9. 1 over f prime of 9. And f prime of 9 is 3. So this is 1/3. So this other information that was given to us is just a distractor. So just be careful with that. Okay, part B. We have differentiable functions f and g. And it tells me g is equal to f inverse. What is the value of g prime of 4? They'll often do this. They'll call it g instead of f inverse, and that's just to avoid that weird notation with like an inverse and a prime. So g prime of 4, again, same kind of formula as before. So this is 1 over f prime of f inverse of 4. So we're going to use the table to find f inverse of 4. F inverse of 4, I'm going to go to see f is 4 at negative 2. So this is 1 over f prime of negative 2. You could have also done this. You could have seen g of 4 and you see that it's -2. So you'll notice, because we already know that g is the inverse, you could have done it that way. And then 1 over f prime of -2, that's 1 over 4. So that's this 4 right here that I'm looking at. And so that is my answer.